billahi minasyaitonirrajim. Bismillahirrahmanirrahim. Alhamdulillahirabbil alamin wassalatu wassalamu ala asyrafil anbiya'i wal mursalin wa ala alihi washabbihi ajmain. Amma ba'd. Assalamualaikum warahmatullahi wabarakatuh. My name is Akmal Fikri Rosli. Metric number 1191446, and inshallah today I will present about the problem based learning, with the topic how equatorial and topocentric coordinate systems facilitate astronomers and amateurs to locate an object in the sky. So first, we will look into the introduction. Since the ancient times, humans have used many ways to locate an object in the sky for many uses in their daily life. In some sense, constellations are humanity's first attempt at making celestial coordinate system. By referencing the constellations, people can get a general idea where to look in the sky. However, there are some advantages and disadvantages when using constellations as a coordinate system. The advantages of using early constellation system are: first, no special equipment needed; then, no science or math needed; and lastly, relatively easy to learn. For the advantages of using early constellation systems, the first one is early constellation systems were not standardized. Then they do not define very precise positions of star. And lastly, they rely on the physical traits of the observer, such as vision, memory, pattern recognition ability, and others. So in order to make the constellations slightly more useful and standardized, a modern constellation system was defined. So in 1930, the International Astronomical Union defined the modern constellation system with its properties. The properties of the modern constellation system are: first, the sky is divided into 88 constellations. Then each constellation is a well-defined area on the sky. Next, most northern constellations are from the Greek or European mythological tradition. Lastly, the southern constellations were given arbitrary names. For example, Antilla, which means the Apam. After that, in order to be precise and accurate in determining a location on the sky, astronomy developed the equatorial and topocentric coordinate system. However, how this coordinate system facilitate astronomers and amateurs to locate an object in the sky. So we will look into the research problem. As we know, astronomy developed the equatorial and topocentric coordinate system to be precise and accurate in determining a location on the sky. This is because the early constellations are not really accurate in determining the location of the stars. So with the moving of time, the knowledge of astronomy is also growing, which causes astronomers to find a more accurate way to determine the position of stars in the sky. The same goes for astronomical equipment. This is because human beings are increasingly advanced and need to be accurate in everything in their life in order to be able to do their jobs efficiently. Because of that, astronomy developed the equatorial and topocentric coordinate system to be precise and accurate in determining a location on the sky. However, how this coordinate system facilitate astronomers and amateurs to locate an object in the sky. So next we will go into the discussion and finding. First we will look about the equatorial coordinate system. So equatorial coordinate system is the projection of Earth's equator, the North Pole and the South Pole on the sky. So there are three parts, which is equator, the North Pole, and the South Pole are projected from the Earth's equator. So first, the Earth's equator is projected to the sky and named as the celestial equator. Then the Earth's north pole is projected to the sky and named as celestial north pole. After that, the Earth's south pole is projected to the sky and named as the celestial south pole. Lastly, the Earth's sky is projected to become the celestial sphere. So, in order to determine a quantitative position on the sky, the concept of Earth's longitude and Earth's latitude are placed on the celestial sphere, called right ascension and declination. So, for its units and notation, the units are the units for the right ascension is the hours of time, from 0 to 24 hours, where 0 hours occurs where the sun crosses the celestial equator on the first day of spring, called the vernal equinox, and the notation for the right ascension is RA. So for declination, its units is by using angles from 0 to plus 90 degrees towards the north celestial poles and 0 to negative 90 degrees towards south celestial poles, with the notation of DEC, which means declination. Frequently in astronomy, angles will be written in a system of 60 seconds. For example, 1 degree equals to 60 arc minutes and 1 arc minutes equals to 60 arc seconds. So next we will look into the topocentric coordinate system. While the equatorial coordinate system is very accurate and precise, it is difficult to use without equipment and computers. Therefore, an easier coordinate system for amateur astronomy is available, called the topocentric coordinate system, also known as altitude azimuth coordinate system. For the topocentric coordinate system, it is defined by the observer's horizon, local hemisphere of sky, with the observer at the center. So first, in the topocentric coordinate system, there are horizon. The horizon is the furthest observable perimeter for the observer. Next, there's also the altitude. So the altitude is the angle of an object around the horizon. Then azimuth. Azimuth is the angle of an object around the horizon clockwise from north. After that, zenith. Zenith is directly above the observer, and nadir is the opposite, which is directly below the observer. And lastly, there are also the meridian, which is the line connecting the north cardinal point, zenith, and the south cardinal point. For the units and notations, the unit for altitude is the angles from 0 degrees at horizon and plus 90 degrees at zenith, and negative 90 degrees at nadir, with the notation ALT, which mean altitude. Then the unit for azimuth is also the angles, which is from 0 degree at north, 90 degrees at east, 180 degrees at south, and 270 degrees at west, with the notation of AZ, which means azimuth. So for the conclusion, astronomy had developed many ways in determining locations of stars in the sky, such as the equatorial and topocentric coordinate system. These coordinate systems are really helpful for the astronomers and amateurs to locate an object in the sky. However, we need to learn about this coordinate system in order to understand and using it in the real situations. Things such as units and notations, the concept of the coordinate systems, and others need to be understood so that we can practice the knowledge in real life situations. So the equatorial and topocentric coordinate system facilitate astronomers and amateurs to locate an object in the sky. So that's all from me for this presentation. Thank you for your time. Assalamualaikum warahmatullahi wabarakatuh.